Hello everyone. In my last session, I introduced you triangle trigonometry. And now in this session, we will be taking illustrations on triangle trigonometry. In last session, whatever formulae we did, I will try to use them if possible. Not necessarily we have to use. Let us start with illustrations. My first illustration is that in triangle ABC, we are given b plus c upon 11 equal to c plus a upon 12 equal to a plus b upon 13. And we are asked to show that cos A upon 7 equal to cos B upon 19 equal to cos C upon 25. Now, nowhere it is written which formula is to be used, which method is to be used. Choice is entirely yours. One tip in the beginning of this session I can give you that you can make right combination of geometry what you have learned and of formulae what we have done in our last session. One, and two, that if anywhere in the figure any naming is required, then it is better that you name that quantity instead of saying angle ABC all the time. If you call it small a or maybe alpha, it would be better. Now, with this given information that b plus c upon 11 equal to c plus a upon 12 equal to a plus b upon 13, what comes to my mind? That three quantities are equal, so they must be equal to something. That something I am writing here as k. Now, recall what you have done in your previous classes. I mean, in previous classes, I mean 9th, 10th standard, etc., where you had done proportion, etc. So, theorem on equal ratios tells me that I can equate it to what? B plus C plus C plus A plus A plus B. That leads to twice of A plus B plus C, numerator, and denominator would be 11 plus 12 plus 13, which is nothing but 36. So 2 upon 36 times A plus B plus C. So it is A plus B plus C upon 18. And that tells me further that I can always write A plus B plus C equal to 18K. Now A plus B plus C is 18K. B plus C is 11K. C plus A is 12K. And A plus B is 13K. Now, if you subtract, say B plus C from A plus B plus C, you would readily get A. Now, similarly, I go for B and C also and I get A equal to 7K, B equal to 6K and C equal to 5K. Now, A, B, C in terms of K are ready with me and look at what is required there. Cos A, cos B, cos C are required. Recall formula of cos A. Does that not need small a, small b, small c? So, whatever we have with us, that we will be using and I will be writing cos A as b square plus c square minus a square upon 2bc, which is the formula, and I would replace b by 6k, etc. And that on simplification gives me 1 upon 5. So cos A is 1 upon 5. Now similarly, I can write cos B and cos C using corresponding formulae and I get cos B as 38 upon 70, which reduces to 19 upon 35 and cos C is 5 upon 7. So we have found cos A, cos B and cos C. Cos A is 1 by 5, cos B is 19 upon 35 and cos C is 5 upon 7. Now denominators are different. So I try to make denominator 35 everywhere and I will write cos A as 7 upon 35, cos B is 19 upon 35 and cos C will be 25 upon 35. So cos A equal to 7 upon 35 tells me that I can write cos A upon 7 equal to 1 upon 35. Now cos B upon 19 I will be writing as 1 upon 35 and cos C upon 25 I will be writing as 1 upon 35. So can't I equate all of them because they all are equal to 1 upon 35. So cos A upon 7 equal to cos B upon 19 equal to cos C upon 25. That would be my final result and that is what we were required to find out or show. Now I think this particular problem has taught you how to use simple cosine rule. Mind you, please, this question was easy because I could use theorem on equal ratios which you have learnt in your previous classes. Now I go to the next question and next question is P is a point in triangle ABC such that angle PAB equal to angle PBA, BC equal to angle PCA and all are equated to omega. Show that cot omega equal to sigma cot A. Now notation sigma cot A may perturb you. Please don't get perturbed. What we mean by sigma cot A, it is cot A plus cot B plus cot C. Fine. We have not done any formula for cot A. If you wish, you can derive like cot A equal to cos A upon sin A, etc. And you start like that. I write cot A equal to cos A upon sin A. Replace formula for cos A, that is b square plus c square minus a square upon 2bc Sin A I have written same as sin A. And that BC sin A reminds me that I can always write it in terms of area of triangle. And hence the last term, B square plus C square minus A square upon 4 delta. Now this is quite interesting that I can write cot A like this. Then I can write cot B and cot C also accordingly. Cot B will become C square plus A square minus B square upon 4 delta. And cot C will become A square plus B square minus C square upon 4 delta. We are interested in finding cot A plus cot B plus cot C. That is sigma cot A. So go for sigma cot A. That will become A square plus B square plus C square upon 4 delta. So at least now I have information about sigma cot A. Now I have to work on cot omega, right? So let us draw the figure. Take that point P inside triangle ABC. Join P to A, B and C so that angle PAB, PBC, PCA can be shown. In addition to that, as I said in the beginning, don't feel shy to give names. If required, better you write their names. So what I have done, PA I have named as X so that my writing becomes easy. PB I have written as Y. Now if I have to go for cot formula, then I will need area of triangles also. So I name area of triangles also. I have written PAB, PBC and PCA's area as delta 1, delta 2, delta 3. So that writing becomes easy. So if I have to write cot omega from triangle PAB, will it not be x square plus c square minus y square upon 4 delta 1? Exactly as how I have written cot A above. Exactly on the similar lines, I write now cot omega from triangle PAB. Now similar exercise I do for triangle PBC and triangle PCA also. And I write 2 more expressions for cot omega. So basically, what I have written in equation 2, 3 and 4, expressions for cot omega, those 3 are equal. And also, does theorem on equal ratio tells you further anything? It tells me that I can also write cot omega equal to, and I add all of them. And when I add x square plus c square, y square plus a square and z square plus b square, I will have x square plus y square plus z square plus a square plus b square plus c square. And then minus x square minus y square minus z square, they will get cancelled. And you will be left with a square plus b square plus c square in the numerator. And denominator you will have 4 times delta 1 plus delta 2 plus delta 3. Look at the figure. Figure says that sum of those 3 areas is nothing but area of the triangle ABC. And hence that cot omega turns out to be a square plus b square plus c square upon 4 delta. Now I have expression for cot omega also in equation 5. And in equation 1, I have already given you sigma cot A. Look at those 2 expressions. They are equal. Means what have we found? Cot omega equal to sigma cot A. Now, entire question was dependent on formula for cot A. I mean, even if you had not derived it, but if you take little pain, then hardly we used anything other than cot formula, right? So we have finally gathered from equation 1 and 5 that cot omega equal to sigma cot A. Now, question is given in the form of show that, but similar question can be always set in multiple choice question type where you will have to do this entire exercise, what we did just now. So it is not that only subjective problems can be set here. I hope you understand what I am saying. When we meet in next session, I will be getting more problems perhaps. Till then, stay tuned. Thank you.